Hey Precalculus. We've been talking a little bit about exponential and logarithmic equations. We've been doing a lot with solving them graphically, and today's notes are going to be solving these puppies using algebra. So if I see an equation like this and I want to solve it, I need to cancel out this 3 in order to bring the exponent down. So to do that, I'm going to log both sides of the equation, and I'll just use the common log. So I take the log of both sides. Now that I do that, I can use my log laws that we learned in the last section to take this exponent and move it out in front. So when I do that, I'm going to put x plus 2 in parentheses. There's a hidden set of parentheses there. So you get x plus 2 times log 3 equals log 7. And now if I want to get x by itself, I'm going to divide both sides by log 3. That gives me x plus 2 equals log 7 over log 3. And then I can continue to get x by itself by taking 2 away from both sides. So I get x equals log 7 over log 3 minus 2. Now this is an exact answer, but most of the time you're going to be solving this using like for a story problem or something, and you're going to want to know what it is approximately. So on the calculator, if I type in log 7, you have to be careful to close this parenthesis before you hit your division sign. So that's something that you might want to like make a note. Close that parenthesis before you hit your division sign, and then divide it by log 3. Close that guy too. So your calculator is going to force you to put parentheses around it. And then you're going to take 2 away from that. And so we would get x is approximately negative 0.2. Let's see, let's go out 4 decimal places. I think that's what the book's going to make you do. So it would be 2287, but since this fifth number is a 5, it's going to round up to 2288. Now if I want to check and make sure that actually works, I can go back to my original problem. 3 to the negative 0.2288 plus 2 should be about 7. And sure enough, it's pretty close. Okay. Now, this is a similar type equation, but if there's a number in front of your base, so this is the base here, because it's underneath the exponent, and here's my base. If there's anything other than this exponential, you have to get it by itself first. You have to isolate the base. So to get rid of the 8, we're going to divide both sides by 8. We get e to the 2x equals, 10 over 4, so that's 5 over 2, right, if I reduce that fraction, or 2.5. And now here, I would log both sides, log, log. But if you have base e, you can actually natural log both sides, and that'll speed the process up a little bit. The reason being is the natural log and e are inverses of each other, and so they cancel each other out, just like a square and a square root do. You can see this on your calculator because if I take the natural log, let's see, of like e squared, I get 2. If I take the natural log of e to the 7th, I get 7. So the natural log and the e just cancel out, and they leave us with the exponent. Which means here, natural log and e cancel out, and I have 2 to the x equals natural log of 2.5. And then I divide both sides by 2, and I get x is approximately, let's see, natural log of 2.5. Make sure to close your parenthesis before you divide by 2. And we get 0.4581. 0.4581. There you go. And again, you could check your answer by plugging it back in. So here, same type of problem. I think right now it would be a good idea to try this problem on your own. So pause the video, do the problem by yourself, and then check your answers. So if you're coming back from being paused, the first thing you should do is divide by 5. We'd have e to the 3 minus 2x equals 2. Since it's base e, we can natural log both sides to cancel the e out. So we get 3 minus 2x equals the natural log of 2. And then you can take 3 away from both sides. Negative 2x equals the natural log of 2 minus 3. Divide both sides by negative 2, and we get x is approximately, gotta remember to close the parentheses here. So let's see, natural log of 2 minus 3. I'm going to hit enter there to get the top of the fraction, and then divide it by 2. 1.1534. Negative 1.1534. There you go. Now, what I just showed you is how to solve exponential equations. You also need to know how to solve logarithmic equations. Here, you're going to cancel out a base by raising it to a power. So for instance, if I have a natural log, I'm going to put e under both sides, like we're raising both sides to that power. This should work. And then these guys are going to cancel because e and natural log cancel, and I get x is equal to e to the 8th, which then you can approximate on your calculator. So on my calculator, if I do e to the 8th, I get 2980.95. Let's see. When I go up 4 decimal places, this is going to round up to a 0, which is going to round this up to an 8. And then if I want to check that, I could take the natural log of this number. So I'm going to hit second A and S to use the whole thing. And it should give me 8 so that I know I did it right. Another way to think about the same problem is that this is base e already. And if I change this to exponential form, I'm saying e to the 8th equals x. So you can either put the e underneath, sort of raising this guy and this guy up into the power, or you can change it to exponential form. They do the same thing. Here, if I want to do that trick of raising it to the power, I'm going to put a 2 here and a 2 here, so that now the log base 2 and the 3 are my exponent. Log base 2 and 2 cancel themselves out, so I get 25 minus x equals 2 cubed, which is 8. And then let's see, if I take 25 away from both sides, I get negative x equals, what's that, negative 17, I think. Divide both sides by negative 1, and I get x equals 17. Now, log base 2 doesn't show up on your calculator, so if you were going to check your work here, you'd have to use change of base. You would say log of the thing on top, so 25 minus x, over log 2. And this is the common log of both sides. So now if x is 17, I should be able to plug that bad boy in and check my work. So log of 25 minus 17 divided by log of 2. And sure enough, it does give us 3. You can also check your work for any of these by graphing and seeing where the intersection point is. The intersection for this guy would be at 17. All right, that's it for these notes. Go ahead and try the couple of problems I sent you guys in the textbook, and I will see you tomorrow. Thanks.